All right, so let's go ahead and do these notes. These word problems, generally speaking, are going to be kind of like Desmos problems, where we kind of graph it and try to figure it out. I'm going to have you close your Chromebooks because I'll just do the Desmos on my screen and you can follow it. Okay, and we kind of started doing a couple of these problems. We saw the one when throwing the ball to the dog and when does it hit the ground and all that stuff. So basically, these are all going to be parabolas. What's a parabola? Circle? It's weird. So a quadratic is an equation. A parabola is a image of a quadratic. It's the U shape. And I know some of you had that question. It said parabola on your homework, and you're like, I don't know what parabola means. It just means that U shape. Okay, so we're going to graph these, and then we're going to figure out what's going on. Okay, before we can write the equate or graph it, we need to be able to write the equation. So looking at this first one here, a company offers a rectangular pool sides with dimensions as shown. Each pool includes a deck around it. If Carolina wants a 15 wide pool with a deck, how many square feet will she need to have available in her yard? Okay, so they come up with this plan and they say, here is the dimensions of your potential pool, right? And all the pools are exactly the same. You have to have a 4-foot deck. And when I say they're the same, if you say I want this to be 10 feet, then this is going to be 20. Okay. So we want to know how much space does she need in her yard? What does that mean we're looking for? Yes, the area of, I like that. So I'm going to go ahead and put area. Do we want to know how big the pool is? Do we want to know how big just the deck is? Or we want to know how much both of them together is? All of it. If you want to put this in your yard, you can't say I want the pool the size of the yard. Why not? Because you have to have a deck, right? How do you get in the pool? You couldn't. Okay, so you have to figure out the whole thing. So we have to figure out how big is this whole thing. So we need to know how wide is it, right? Because area for this, and how is length times width, and what is the width of this? And of course, it's not just given. They give us these parts. Let's go with the width first. Can somebody tell me what they think this is? It's not just X. You see how it stops short there?
Oh, it's 4X.
Brody?
It's like X minus 8.
It's not minus 8. Yeah.
8X.
It's now 8X means whatever X is, we're going to times it by 8. Okay? It's not that. It's X plus 8. Will you shut the door for me, Timothy? It's X plus 8 because this right here is X, and then we're going to add 4 here and add 4 there. So this total side here is X plus 8. Can we see that? So what's the other one going to be? 2X plus 8. Okay. It says write a quadratic function to represent the area of the pool and the deck. So we know length times width is going to be X plus 8 times 2X plus 8. And I bet you anything that you want to do what to that equation? It's not factor. So you put it in standard form or FOIL it or unfactor it. I know what you meant. Okay. But do I have to? Does it say what form you need to write this in? No. Here's the thing about this. If I were to rewrite this into standard form and make a mistake, then I have to take points off. If I leave it like this, it's still right. Okay. So you might as well just leave it in the easiest form unless it asks you to change it. Okay. All right. Technically, this is an even and factored form. It's in no form. Why is this not in factored form? And some of you asked, can I do this at the end when I factor?
No.
Do what?
I don't know.
The answer is yes, you can do what at the end if you forgot to do it at the beginning.
Why?
The GCF. Okay. Do you remember I said if you have a GCF in here,
Yeah,
you can take it out. So technically, this isn't even all the way factored. If you didn't understand it, that's fine. Okay. So we're supposed to find the area. Okay. So then it says if Caroline wants a 15-foot wide pool, okay, with a deck, how many square feet? Okay. So all I need to do now is do what with my equation? Plug what in? Plug 15 in. Now we got to be careful because sometimes they'll give us this value and sometimes they'll give us this value. And we use in 15 is this here, but yeah, all I got to do is plug in 15. And I don't know about you, but that doesn't bother me that that's in this weird form. I actually kind of liked factored form. Bless you. Go to my calculator. Do you ever like to go, well, I know that that's 23 and that's 38. And we get 874. Okay. So what is the answer to the question?
874.
Word problems get word answers.
The yard's pool and deck is gonna take up 874 square feet.
The pool and deck will take up 874. What was our units? Feet squared. Yep, square feet. Okay. Strawberry lemonade. This next problem was actually kind of on your last test. A rectangle's area is modeled by this. Find the following. What do we think the length and the width would be? Remember grading this one? Kind of like this?
Mm-hmm.
Yeah. Yeah. Okay. How'd you get that? Okay. How do you find, it's a rectangle. How do you find area of a rectangle? Length times width. So length times width, which means something times something. So what do you think we need to do to this problem? Undistribute. Factor. We need to factor this. And if we have it as something times something, then we'll just say the smaller one's the width and the larger one's the length. Okay. How do we factor this? Okay. Yep. We got to X box it. So I'm going to kind of take up space here. Don't want to write too big. So we get negative 24, negative 10. I do need a box because we have an A that's not equal to 1. Parker, you got it? That 6 and 4 really throws us off, doesn't it?
What is it? Is only like it's the top and the bottom?
Yeah.
Negative 12 and 2. Okay, so then it's 3x squared. And I really hope at this point we're like, factoring is easy peasy, strawberry lemonade. Negative 4. Factoring should be something that I can like wake you up in the middle of the night and say, factor this real quick. And you're like, and you're not. Do you know what strawberry lemonade means? Do you know this? Huh? Easy peasy strawberry lemonade? Yeah. Yes.
We had a bet over that. Okay, she didn't know.
Have you heard me say that before?
She
I feel
thought.
like you told me.
Oh, okay.
Yeah, she did.
Why are you in my house at night asking me about
It's good for you.
I'm trying to sleep.
Oh, yeah.
To fill in some of those.
My first
I think you
lesson.
get your
You have
teacher
to walk
card
in the
taken
door.
My teacher card. All right, looking at these, we always call which one longer, the length or the width? Length. Which of these has to be the length we know would be the longer of the two? The 3x plus 2, we would say that's got to be. And on our test, this question wasn't what's the length and the width. The question was what's the perimeter. And some of you knocked it out, and some of you were like, "Wow, I'm really lost." But now we're doing it again. So perimeter. Some of you told me the perimeter was 4x minus 2. Why was that wrong? They just added these two. Because they said, oh, this is x minus 4, this is 3x plus 2, and they said just add them, and you get 4x minus 2. Add all the sides. Well, this side over here is 3x plus 2, and this side over here is x minus 4. So that means I have 3x, 4x, 7x, 8x. In numbers, I got minus 4. Is that right?
Yeah.
So reasonable domain. What that means is what values can I plug in for x that make sense? So sometimes it's easier to ask what doesn't make sense. What values for x would not make sense? And you might not know where to look, but you might be able to figure it out. What? Huh? 1,000. We have no idea what this is, right? So because we don't know what it is, that makes it tricky, right? If we're talking about your bedroom and you're like 1,000 feet, you're right. That would be unreasonable. But because we don't know what it is, we don't know. We can't say 1,000s. Okay. Think you're going the wrong. We're going the wrong way.
Undefined.
Negatives wouldn't make sense.
Undefined.
-8 wouldn't make sense. So we want the numbers to be positive, but also what?
X is so 0 is less.
What's the smallest value I can have for x and not be positive or not be negative? 4. What is she talking about?
I have no idea.
Because we have a negative.
So it cancels it out.
So right here they're telling us that x has to be bigger than 4. Otherwise it makes no sense. So reasonable domain, x has to be bigger than 4. Can it be equal to 4? No, why not? Can you have a length or a width of 0? If you have a width of 0, what do you have? Nothing, right? So it's got to be at least bigger than 4. What's a reasonable area? So the outcome is the area. Yeah, Brody?
X is less than 2.
X is less than 2. Why do you say that? And it's an outcome.
Because X is greater than 4 and it has a minus, so it should be the opposite. So it has a plus.
Okay. I'm not sure. Josh? Okay. I see why you picked that. What do you think the smallest outcome we could have is?
2. More than 2.
Close to 1. We could be a little bit, we could make this really, really, really thin. Say it again. Could it be 0? No. But it could be a little bit bigger than 0.
0.000.
How do you say just a little bit bigger than 0?
1/2.
That's way bigger than 0.
0.01.
Okay. Yeah, kind of.
No, there's a word for it.
How do I say this outcome is going to be?
Less than 1.
You say
Greater than 0.
I almost gave it away.
Oh,
How do you say what?
0 is less than X.
Yes. But range is always what?
Why?
Y. So what we're going to say is that y is going to be greater than 0. Can it be equal to 0? No, because that would be nothing. Okay. Now, I like I like the thought of 1,000. So if I change this and said bedroom, right? Then we start changing this and we're saying, what's a reasonable bedroom? How big does it make sense for a bedroom to be? Anyone know how big their bedroom is?
About 30 feet, I believe.
Well, we're talking about square feet.
I think mine's.
How big do you think this room is? Would this be a big bedroom? Yeah. Okay. I think this room is like 30 feet by 30 feet.
Yes, that's 90. No, not. That's not. Yeah, no. 900.
900.
It's actually 900.
So if I were talking about a bedroom, I might say y is going to be greater than 0 but less than 900, right? And x has got to be greater than 4 but less than 30 or something like that. Okay? Those would be reasonable.
So how much square feet is this whole?
I don't know. Yeah, it's a
Well,
lot.
probably-
Right, and that's where I was saying this rectangle, we don't know. It could be a warehouse. It could be a rectangle you drew on your paper. We don't know. So
I don't know where I was, but I was like, when they build those really, really big warehouses, there was a sign that said it was like 1 million square feet, and I could not even. That's
Yeah.
a lot.
it's a lot.
That's not big.
It's a lot.
All right, so I find this extremely fascinating, but they realized that this formula works for any time an object is thrown or dropped or a rocket. Okay, this formula is used for many things. We're going to talk in a second about why this formula is offensive to science teachers, but we'll talk about that in just a second. Let's talk about the different parts. So they're saying that it's h of t. What do you think h stands for without even reading it? Height. So h of t, that means height. And t is time.
You saw that on the paper.
Okay. What do you think v actually let's do h sub 0. What did we decide h meant?
Height.
What does 0 usually mean?
Zero.
Like your start.
Your start. This is your starting height. Anyone know what v might be? It's v of 0, so 0 means starting.
Velocity.
Velocity. What is velocity?
The speed at which you're going.
It's speed with
Force.
None. With distance. Mass and distance.
A number.
Distance is the closest to the baddest thing you have.
Distance and time.
speed with.
Time.
Let me put it to you this way. My velocity coming here was, I don't know,
Distance.
30 miles per hour. My velocity going home is negative 30 miles per hour.
Oh. Distance at where you
Say again?
Distance and time.
Distance at like what
No.
you travel.
Distance and
Distance and direction.
It's direction. It's speed with direction. Okay? Velocity means speed with direction.
Have you seen this cool meme? Because Vector, he like kind of talks about that because it's the same thing.
Yeah. So if we're throwing a ball, what does it mean, speed with direction? What do you mean direction, Mr. McConnell? I'm just throwing this ball. Well, how can you throw it? Say it again. Right. So give me one way I could throw it. Okay. So, I could throw it up, or I could throw it down. So that's where that throwing it down would be a negative velocity. Throwing up is a positive velocity. What do you think negative 16 is?
the height at which you throw it.
That's always the same. That's not a number that's going to change.
Wait, I got it right.
No. Sorry. Womp, womp, womp. What doesn't change? Yeah.
The slope.
It's a constant. What's a constant? What's the main thing acting on something when you throw it?
Gravity.
Gravity.
Isn't gravity like 9 something?
Yes.
What if you're that was at 9.8? What if you're in space?
Same.
Gravity.
We talked about.
If you in a black hole.
So here's the thing about.
I was confused about.
We got about 10. I want to give you the 10-second. What about space thing? When you're in space, you're moving this direction at a speed so that you're beating gravity. Now, what do I mean by that? Gravity is actually acting on you and you're kind of falling towards Earth, but you're moving also away from Earth at the same time. At a constant, you're moving away at the same rate as gravity. So what does that mean?
So you just stuck there.
Zero.
Gravity feels like
A zero.
0. What does it mean if gravity feels like 0?
Then the thing's 16.
Then you don't.
Then it feels like you have no gravity. Do you have gravity?
Yeah, there's still gravity.
Yes, but you have another force that's equaling gravity.
What's the other source?
So therefore, your speed as you're moving away, okay, is exactly the same. If your speed moving away wasn't the same speed as gravity, what would happen?
Wait, what'd you say?
If your speed wasn't the same as the speed of gravity, what would happen?
If your speed is less than gravity?
If it's less than gravity, gravity would win.
More than gravity, you're gonna go away.
You're going to go away from it. When you want something to orbit the Earth, what do you want it to do?
The same.
You want it to stay the same distance. You want it to be equal to gravity. Okay? All right. That's the gravity talk. Okay. Why do science teachers hate this formula?
Because gravity is gravity.
And I heard somebody say, isn't gravity 9.8?
9.8?
Yeah.
That's 16 is
Cheating.
it's not actual.
Okay. What do you think's offensive to them in this formula?
I know. Since it's greater than or no, it's less than. I mean.
Okay, I like the thought.
No.
What do science teachers always? What are the units always for science teachers?
Crazy.
M
What is M?
M is meters.
Meters.
And then like slash.
So Mr. Bauman and I would have conversations, and I always talked in feet. He always talked in meters, right? And I could never get him to go, well, that's feet, right? I showed him this formula before he went to a better place, and he was like, no, he went to Cincinnati. Isn't that better than? Oh.
He didn't want to.
Am I using that expression wrong?
Why not go with you and say he went to a better place?
So a science teacher saw this, Mr. Bauman saw this formula, and he said, I've never seen that in my life. I have no idea what you're talking about because it's in feet per second, not meters per second. So there's a version. Now, here's the weird thing. Math always does feet per second, at least in the US. Science always does meter per second. Okay? So in some ways, we don't talk in the same language. Okay?
Is there a way we're supposed to solve this?
Yeah. This particular one, no, we're just talking about it. Now, looking at this next one. If you have these two things, the initial velocity and the height, you can predict every moment, every second of this person's movement or object's movement. This is how we get things into space and get it to stay there. Okay. A diver jumps off a platform at initial velocity of 15 feet per second. Okay. What do we need here? I feel like something's missing. Oh, no, there it is. I thought this is, okay. And the initial height, so my height's initial is 30, okay? I'm going to go ahead and call that H what? 0. H sub 0, meaning the initial height. Can somebody tell me what is the function for this? We'll go ahead and use y equals because I think we like that.
Wait, what did you negative 15?
Nope.
No, 5.
Negative 16
Oh, that's
t squared plus 15t plus 30. Where did that come from? It's this formula right here.
It never changes.
Yeah, this is that formula. All I do is replace the velocity with 15, and 30 is that. Why is 16 negative here?
Because you're going down, or like falling,
What is?
the person.
Okay.
No, gravity always makes you go down.
Gravity's always making you go down, so that's why that's negative. So what's a quadratic formula or a quadratic function? Boom, we did it. Okay. It does say make sure to use
This into an Xbox to solve it, but you don't have to. It doesn't say.
3, 2, 1. Let's refocus. So it does. Here's something I want to point out for online. I wouldn't care if you use y and x here, but online, if it tells you to use h and t, then we should use h of t equals that. Okay, on paper, I wouldn't mark it wrong, but online it would. Okay, how many feet above the platform will the diver be at the highest point of his dive? So now we're to the point where we're going to jump on Desmos. Simply type this in, y equals negative 16 t x squared. I think it likes the x variable. In high school? No. You're in high school. What do you mean? So questions you could be asked would be like that one we already knew, this one, and this. Okay. So the question said, how many feet above the platform will the diver be? So sometimes people want to answer this as 33.516, but that's wrong. It's 3. How far above? So he went 3.516 feet. Because it said how many feet above the platform.
The platform's at 30.
Okay. If it said how many feet above the water, okay. Tell me about this point. What is this point telling me?
That's
Where he landed.
That's
Or how
long it takes him to hit the water.
Takes them less than 2 seconds to hit the water. Okay. Now, this information could be super valuable to a diver if you're like for example, wow, your vertical wasn't as high as you should have been, or you're hitting the water too quick. I don't know anything about diving, but I'm just saying you could definitely say, like, if you're hitting the water too quick, then you're not jumping high enough. If you're not jumping high enough, you don't have enough time to do spins or whatever you do. I don't know. Okay. Same type of question, but different thing. Find the diver's maximum height above the water if he dives from a 20-foot platform with initial velocity of 8. Can someone give me the equation? Negative 16 t squared plus 8t plus 20. Now, I want to point out this question doesn't say give me the formula. It says how high will he be? So we go over here and we got to just change this. So he doesn't jump with as much acceleration, and he's jumping off the lower one. Okay. Someone pushed him, right? We're okay?
Yeah.
Okay. So what's the answer to this? It's not 1 foot.
It's go down to the bottom.
So let me read the question. Find the diver's maximum height above the water if he does this dive.
Can you move your mouse down?
Oh, you can't see it?
No, down. Yeah, right.
There we go.
You want to see that?
1.39.
Okay. Oh, how long until he hits the water?
3.1.
Okay, you're answering the other question.
What's your? Oh.
We didn't answer the question up here. I just wrote the formula.
Oh.
What's his maximum height above the water?
21.
21 feet. Okay, so we got to be careful. Make sure we read the question, because if the answer was how high is he above the platform, it was 1. That's not really hard. We just got to make sure we're answering the question. Okay. Next question. You were a swimmer, right? No. Okay. Just kidding. A ball is thrown vertically upwards with the speed of 32 feet per second. Something's left out here. What do you think we're going to assume?
It's gonna have to be an X.
Where he threw it, where he threw the ball.
Okay.
And plug in like a point.
Okay. So we need our equation.
How high up he threw it.
I see what you're saying by a point. We're not. It's not quite that, but I like that.
How high up he threw the ball from.
So we need to have an equation to start. So what's our equation?
It's negative y equals negative 16
Mhm.
squared plus x plus plus 32 t plus x. Is that it?
32t,
Plus x.
because we don't know
I
that.
don't know where. Yeah.
Okay. What's the assumption here?
It starts at 0. He starts at 0.
We're going to assume that he's starting throwing it from the ground. Does that make sense?
Wait, how would he throw it from the ground?
That's a good point, right? So I think what he's saying is I'm 5'11". If I throw a ball, I'm probably throwing it from 5 feet. Okay. So we can say that this is from 0 just means from where it started. Okay. So, and it doesn't, so the assumption is that once it gets back to 0
It's where he stands.
is where he's going to catch it. He's going to throw it and catch it from the same spot, make it kind of zeroing it out. Okay. So we're just going to do it from that. You're right. Is it going to be super accurate? No, it might be off by that distance, but we'll see. Okay. So negative 16, it's kind of nice that these are always just switching these numbers around. Okay. So find the highest point. So we have 3 points here. What's 0, 0 mean?
That's where it starts.
Starts and how, so it's 0. He hasn't thrown it yet, right? And then it gets up to there and then it comes back down there. So I've done enough to answer these questions. The highest point it reaches. 16. Do you see how we wouldn't say 1 comma 16? Because 1 means what?
1 second.
1 second. We don't, it doesn't ask about time on this part of the question. And do you see how our max is 16 at 1 second? Remember we kept talking about the max there? Okay. So its highest point is 16 feet. The total time in the air.
3 seconds. Would it be 3? Wait, because if he throws it up, it's 1, and then it takes 2 seconds to hit the ground, so it's 3 seconds.
Okay.
I think it's 2.
Okay.
2 seconds.
It's 2 seconds. It's up, takes a second to get all the way up, and then a second to get all the way down. Okay. 2 seconds. And I could ask all kinds of questions. How long is it traveling up for? 1 second. How long is it traveling down? 1 second. How fast is it traveling at 1 second?
Well, if you have to multiply, don't you have to multiply gravity?
Good, Jasper. It's 0. At 1 second, it's traveling 0 miles per hour or 0 feet per second. Okay. This is what they do when you want to experience weightlessness. They take you in a plane, they get you up to this peak, and then they drop. And for this small little bit of time, you feel like you're weightless because your gravity and your speed goes to kind of 0. Okay. This is also why on a roller coaster ride, your stomach feels like feels funny, right? Because you're all of a sudden you're not experiencing gravity, and then all of a sudden you are. Okay. Last question. A ball is thrown vertically upwards with a speed of 95 meters per second. Yeah. It hits the ground at 6 seconds later. By modeling the ball as a particle, find the height above the ground from which it is thrown. Yes.
Is the equation y equals negative 16t squared plus 95t plus 6?
Yeah. No. But super close. Why is it not that? And it wasn't really fair to have that.
Is it minus 6?
Okay. No.
Is this speed not
There's something small and tricky on this, but this would make Mr. Bauman happy.
You have to plug it in to desk and see where it
Oh, it's meters per second.
It's meters per second. which means we can't use negative 16. We got to figure out the speed of gravity in meters per second. Here's a thing I want you to know. There are no questions like this online, okay? And I don't think there are even questions like this on this paper. I strictly did this question because Mr. Bauman said it would be wrong for me not to, okay? So right here, it says gravity in meters per second squared is 9.80665. What do you think we call that in middle school math? Well, it is a decimal, but we're going to call that 9.81, okay? So gravity is also equal to 9.81 roughly meters per second squared, or 16 feet per second squared.
I have a question.
Yes.
Do you gain velocity if you're falling from like a really high place?
You do not, because you eventually get to the speed of gravity. But generally speaking, wind resistance becomes a factor when you're just straight falling.
Wait, so you can never reach faster than gravity if it's just you falling down?
I believe that's correct, without any other force happening on you. Okay. So if you jump out of a plane and you jump 100,000 feet, or that's probably too much, 1,000 feet, and you reach this, they call it terminal velocity, which just means you can't go faster than that's pulling on you. Okay.
Then how do meteors like destroy the entire Earth?
Say again.
How do like meteors destroy the entire Earth?
Because they're not being pulled by gravity. They have a force that's pushing it towards us. For an object to move through space, everything in space has gravity. For an object to move through space, it's got to be beating all the gravities that are on it. Have you guys done the round circle thing in science where it's a big like spandexy thing and you drop the marbles around?
No, but I know what you're talking
Okay.
about. Yeah.
So that's all this coming into play, right? So if you want to be not affected by gravity, you got to be traveling faster than it. Okay. So we're gonna just appease Mr. Bauman, who's in a better place. Rest in peace. The formula is y equals. Tell me what it is. Someone want to tell me? Maya, you want to take a shot at it?
Is it y equals, is it a negative or just minus?
What do you think? Which way is if it's in meters per second, does the gravity still pull down?
Yeah.
Yeah.
Negative 9.81 plus 95 t plus 6.
We missed one thing.
Oh, square.
Where?
T squared? 9.
We got to put a T there. Okay. So this is meters per second. Again, I'm not going to quiz on this. Okay. Because for some odd reason, we always use feet per second. I'll also tell you that a lot of AP calculus is based on motion. A lot of calculus, when you do that, will be based on that.
Wait,
Did I make a mistake?
isn't 6? It hits the ground 6 seconds later.
Oh. Oh, okay. Oh, yeah. Good call. Okay. So the ball is thrown vertically at a speed of this. It hits the ground 6 seconds later. Thank you. So what does that mean? Do we know its initial height? No. But this is where, I think this is, Maya said it, that we got to use that point to find the initial height. What is our point that we're going to use? We're not going to use 0, 0. That won't do much for us. Close. 60, right? We know after 6 seconds it's going to hit the ground.
Oh, I forgot which one was actually.
Okay, good. Thank you for that. Okay, so what we're going to do is we just plug this in, and we need to solve for h sub 0. So we're going to go 0 equals negative 9.81 times 6 squared. You could have a question like this where they give you some information, and you have to find the part that's missing. It just won't be in meters squared. So go to my calculator. I'm going to go negative 9.81 times 6 squared plus 95 times 6. And I get, did I make a mistake? Did you get that? 216?
Yeah, she never.
Uh-huh. So let's just go with it. Okay, so then I get that that's 216.84 plus h sub 0 equals 0. I pause because I'm going to subtract it, and I get h sub 0 equals 216.84 negative when I move it to the other side. Okay, the math tells me that its initial height was what? Okay, so I'm going to just go with this. It says find the height above the ground from which it was thrown. That's a little tricky because it wasn't. What do we say? It was thrown from where? What does a negative mean in this respect? Down here, this negative 216. Yeah, it's underground. It was thrown from 216.84 meters below the ground. Now, I have a feeling, I wrote this question, I have a feeling I didn't mean for it to be that, but the math, that's what the math is saying. Are there anything that we have that we shoot from below the ground? We have rockets that are underneath the ground. Okay, so in theory, I could have been talking about this. This person has a very strong arm if they're doing that. Good job today, guys. Thank you.